So, picking up where we left off the last class, we are dealing with limits and the formal definition. The difference quotient involves valuing a limit as h approaches zero. And by doing the limit process, you are actually finding what when you do the limit process? You're finding an equation, and that equation represents the what?
The slope of a certain.
It represents the slope of the tangent line at a particular point along the curve. When you go through the process of finding the limit as h approaches zero of the whole difference quotient, you are finding the slope of the tangent line. That's also known as the what? One word. Starts with a D.
Derivative.
The derivative. That's what you are finding. Okay? So you had a few problems that you worked on in class at the end of class, and you had to finish up this problem and then the next problem from the notes for homework. So you should have done the limit as h approaches zero, making sure this is along the side of every line that you did. Yes? Good stuff. Then the formula says, or the difference quotient says, f of x plus h minus f of x all over h, the limit, as you approach that. So the first part, you're supposed to plug in x plus h into every x that you see. Then you subtract the function. Whatever the original function is, you subtract it, and then you divide by h. This is how you guys should have started, right? No.
Why'd you put the x or 1 over?
Because the original function is 1 over x. So in the original function, wherever there's an x, you replace it with an x plus h. So if x is in the denominator, you gotta plug it in there. After this point, it's all about simplifying, because if you try to plug in 0 in for h, you'll end up getting x, 1 over x, minus 1 over x, which is just 0, all over 0. And when you have 0 over 0, what does that mean? Say again? You can simplify it, which we can, okay? Using a little bit of algebra, we simplify this fraction up here. Now, in order to subtract two fractions, I need a what? Common denominator, which is going to be x times x plus h. So I'm going to multiply this whole first fraction by an x, this whole second fraction by an x plus h, just so I can get a common denominator here. If you did it differently, you know, hey, it's all whoever taught you how to do fractions, so. All I'm doing at this point is simplifying. So that way, when I plug in 0, I don't get 0 over 0. I'm actually trying to figure out what this limit is. Now that we have the same denominator, we can actually subtract the numerator. Now this negative applies to this whole second fraction, which means that this is actually going to be a minus x and then a what? A minus h, because that negative applies to both parts in that second fraction. Everybody still with me? So at this point, the x's cancel out, and you're left with the limit as h approaches 0 of h all over.
Would it be negative h?
That it would be, thank you. Questions up to here? All right. I have a fraction within a fraction, which means that I'm going to multiply by the reciprocal. When I do that, I'm basically multiplying this whole top fraction by 1 over h, which will turn into negative h all over h x plus h. Everybody see that? Like, I don't want to write out that extra step, so I just went ahead and do that there. This is what you end up getting. Then you notice that your h's are going to what? Cancel out. So you're going to be left with the limit as h approaches 0 of negative 1 all over x times x plus h.
Is that fine if we wrote x squared plus x?
Yes, you could write it as x squared plus x8. We could do that next step. that next line, but basically there's no more simplifying that we can do. So when we actually go to plug 0 in, we're going to be left with negative 1 all over x times x, which is x squared. And that is the derivative.
Pardon the interruption, teachers.
So then again, we're left with our derivative here. Dy over dx equals negative 1 all over x squared. Other questions on this? So that's the process, using the limit process to find the derivative, okay? You use that formula, evaluate the limit as h approaches 0, do your algebra as you need to get to the final answer. Now this one, you gotta do one extra thing. Use the difference quotient, which is just the formal definition. And then once you got your answer, you actually had to plug in 1. Because it asked you for the gradient. What does gradient mean?
Slope.
Actually wants you to find the slope of the tangent line at that particular point. So you had to go through the limit process. Because there were 2 x's, you actually had to plug in x plus h twice. So everybody see that for that first part? Everywhere there's an x, you have to plug in an x plus h for that very first part. Then you have to subtract the entire function. You always put that in parentheses so you don't forget. You actually have to distribute over that negative, and all of that is over h. At this point, if you were to plug in 0, you would end up the numerator completely going to 0, and of course the denominator is going to be 0. So you have 0 over 0, which you can't have. So you FOIL, distribute the negative, and then combine all the like terms within the numerator. Okay? What you should notice, the x squares cancel out, the x's cancel out, and the 2's cancel out, leaving with only terms that have an h in them. So that's a 2xh plus h squared minus h all over h. Questions on this? Then, what do you do from here?
Factor out h.
Factor out an h, so that leaves you with the 2x plus 1h minus 1 all over h. The h's cancel out from this point. You're left with the limit as h approaches 0 of 2x plus h minus 1. When you go to plug in, you'll have your derivative, which is 2x minus 1. When you go to plug in 1, what do you get? So, do you notice anything? Do you notice any type of pattern between the original function and the derivative? I mean, take a look. How do you go from the original function down to the derivative? Like, is there anything that you notice? Is there anything that you notice? So what are some things that you notice?
Oh, the exponent, right?
What about the exponent?
The exponent down.
Okay, the exponent is like that brought down?
Did you do that?
Yeah, you can definitely do that. I mean, that makes sense why you get the 2x. Why you get the 2x, does it work for, what about for this one? Does that work?
You can bring 3.
Yes.
Okay, so that'll give you 3x, but where do you think, how do you think we got that second? At 2.
What if we subtracted
1?
Subtract 1 from the exponent. Well, 3 minus 1 is indeed 2. Let's see if that works here. If I bring the 2 down front, that'll give me a 2x. What's 2 minus 1? A 1. So yeah, that works there. This one here. Oh, there's a number in front. If I did the same thing that you guys were talking about and I brought the 2 down, where do you think the 6 came from?
3 times 2.
You multiply. So you have 2 times 3, which gives you 6, Following the same concept, subtract 1. Yep, you get that. What about this one down here? This one over x. How would I do that one?
It's a negative exponent. I mean,
How so?
x to the negative 1.
X to the negative 1. Okay. So, do we follow that same concept, right? Bring that down to the front. That gives me the negative x. Subtract 1. Negative 1 minus 1 is? Negative 2. And concept from algebra 2. Loss of exponents. Look at you. Yes. Yes. How do you get rid of the 1? And the 2, because I mean the 1's not there anymore, right? That is a good question. How do we? Anybody want to take a stab at it?
What if it could be like an x to the 0 power next to it?
I mean, it could be. I mean, look, it goes from x to the second, x to the first. So I mean, that only makes a logical sense. X to the 0. When I bring 0 to the front and I multiply, what's 0 times 2? 0. And it goes away, just like that. So yes. But yes, all these things are very true. It all comes down to a power rule. There is a shortcut to finding the
Miss
derivative.
Anderson, why didn't you show us this?
I'm sorry.
You guys doing 18 steps.
Well, I mean, it's all for a purpose. I mean, if they ask you to show use the formal definition, you have to know, okay? And plus, we have to cross the burning sands together, okay? You have to go through the fire to get to.
Circle.
There you go. It all comes together. Yes, the power rule. It is called the power rule of a derivative of x to the n. If n is a rational number, that's a whole number, a fraction, a negative number. Then to find the derivative, all you do is you bring the exponent down to the front and then you subtract 1 from your exponent. That is the power rule. You can use that. So no more long formal definition unless they ask you to do that. What will be the derivative of a?
5x to the 4.
5x to the 4, because you bring the exponent down and then you subtract 1 from it. Okay? Look at B, the derivative. Remember, you bring the exponent down to the front, you subtract 1, so that turns into what?
3x squared.
What are you looking at?
Oh, wait, I'm at
It's an A. It's an A. It's an A. What would that one be? 8x to the 7th. There we go. Now, one's like this, just like 1 over x. You do need to apply the fact that you have to bring it up. So this is the same thing as saying x to the negative 4. Okay? Always make sure you bring up these type. So then the derivative,
Negative 4 over x.
it would be negative 4 over x to the 3rd. If you're like, how did you get that? You do, well, not to the 3rd, actually to the what? Negative 5th. But then you want to write it as a positive, so it'll be negative 4 over x to the 5th. I'm running out of space, but I would include the notation. Does everybody see that? Bring the exponent to the front, subtract 1, and then make the exponent positive. Okay? Make your exponent positive. Now radicals.
X to the 1/3.
They can be written using rational exponents. This is going to be x to the 1/3. Same rule, same concept applies. You bring the exponent down to the front. That turns into 1/3 x. What's 1/3 minus 1? Negative 2/3. But you have to turn it into a positive. So then, when you turn this into a positive, that means you technically have to bring this x down to the denominator. So then this will be like so. Because the 3 is already in the denominator of that fraction, so you gotta make the x join. Okay? Now you can leave your final answer like this, or if you want to write it back into radical form, that is also acceptable. Remember, your denominator is your root, and your numerator stays with your base. Either one would be acceptable. It would be on the outside of the radical because only the x is being raised to the 2/3. Everybody see that one? So we bring it down to the front, subtract 1. We have to turn this exponent into a positive, so we bring the x, because technically this is x to the negative 2/3 over 1. We bring it to the denominator to make it positive. 3 was already in the denominator, so we bring it with the 3. And so this could be fine, this would be acceptable as an answer, but if you want to write it in a radical form, the denominator is the root, and the numerator stays with it. I want you guys to give E and F a go. Give E and F a go. Alright, with these, okay, remember that this can be turned into 1 over x to the 1/2. Then you can bring it up to the numerator by making it negative. So then your derivative would be a negative 1/2 x to the negative 3/2 if you were to subtract 1. Make it positive. The exponent by that, I mean, it would be a negative 1 all over 2 x to the 3/2. And you could leave it like that. However, if you wanted to, you could rewrite it like so. Okay, we got that. Or either one of those two. Over here. Can we write it as x to the 3/5? So then the derivative would be 3/5 when you bring the exponent down, and then subtract 1, which would be a negative 2/5. Make it positive, so that'd be a 3 over 5x to the 2/5. This would be acceptable as your derivative. But if you wanted to write it with the radical, it would be the 5th root of x squared. Raise your hand if you got that one. Questions on using the power rule? Well, the power rule is in conjunction with these other rules as well. It's called the constant rule, the sum and difference rule, and the constant multiple. Which you guys kind of already deduced a little bit when we were going through the whole trying to figure out what's the pattern. But anytime you take the derivative of a constant, it's always going to equal 0. That's why the 2 went away. That's why the negative 1 went away. That's why the all those constants went away when we did the derivative. Sum and difference basically says when you have multiple pieces of a function, such as x to the 3rd plus 2x squared minus x plus 3, you basically are taking the derivative of each individual single term. Okay? So if I wanted to find the derivative of this function, you would find the derivative of 3x of x to the 3rd, which is what? 3x squared. You would take the derivative of 2x squared, which would be what? 4x. And then the derivative of negative x minus 1. Derivative of a constant is always 0, so that goes away. So sum and difference rule basically says you're taking the derivative of every single term. Okay? And then the constant multiple, which I already did, if there's a constant out front of any one of your terms, you just multiply it. That's why that 2 turned into a 4. Okay? So you kind of already had that deduced. I just wanted to make sure that you knew they were rules that went along with it. Okay? So, with these next ones, we are, and you have, that extra space right underneath this slide, so use that for these problems as well. You're going to find the derivative of each one using the basic rules, not formal definition, the rules we just went over. You're going to find the slope at each one of these indicated points, and then you're going to use your graphing calculator to confirm it. Okay? x to the third? 3x squared. You bring the exponent down, subtract 1. What about 2x squared? Well, it's 4x. What about negative 15x? Minus 15. What's the derivative of negative 13? 0. So there's your derivative. Now it's asking you to find the slope of the graph at each one of the indicated points. Now, these points are on the graph of this particular curve. But when you're trying to find the slope at these particular points, you're only dealing with the x value. Do not let the y value throw you off, okay? It's just those particular points that are on the curve, but you only need to use the x. So all you're going to do is plug in negative 3 for x to figure out what the slope is at that exact point, and then plug in positive 3 to find the slope at that particular point. Does everybody understand that? Okay, let's plug in negative 3. What value do you get? 0. Let's plug in positive 3. What'd you get? Questions up to here? Now, to use your calculator to do this, this is just to confirm. This is just to confirm. All right? What you'll do is you'll go to math. You'll press the math button. You'll go down to option 8. Option 8 says in derivative. Option 8 says in derivative. Okay? Now, if you raise your hand if your calculator looks like mine. Okay. If your calculator does not look like mine, it's fine. Just hold on for a second. I'll show you what to do for the other one. Okay? You basically have to fill everything in. This right here, remember that notation I showed you to represent derivative? D over D. Yeah. What's going to go here? dx. D over dx. So you have to plug an x in there. That next space is where you actually plug in the original function, okay? You plug in the original function, not the derivative, the original function. Can somebody read off the original function to me?
Yeah.
X cubed
Plus 2x squared.
2x squared
Minus 15x.
minus 15 minus 13. Then you type in the original function. Then it says x equal blank. That's where you actually plug in the x values where you're trying to find the slope at that particular point. So for negative 3, I plug that in. And it gives me 1e to the negative 6. That's just you move the decimal place back 6 spots, which is basically 0. I can do the same thing with positive 3. I'm going to cheat. I'm going to go second enter, which brings up the exact same line I had before. And I'm just going to move back and delete that negative symbol. Click enter, and I get 24.001, which is basically 24. Okay? Now, if your calculator does not look like that, it popped up the words in derivative with the parenthesis. You yourself, you have to type in the function.
Do we need to put parentheses on the function?
No. You type in the function. You press the comma button. Comma is located right above the 7. Then you'll have to type in x, because you basically got to let the calculator know that you're doing the derivative with respect to x. Type in another comma. And then type in the value which you want to find the derivative. If you want to find 3, you'll type in 3. If you want to do negative 3, you'll type in negative 3 and you close it off. When you click enter, you'll get the same result. Now, so you're going to do B, C, and D on your own. B, C, and D on your own. All right, for B, what did you guys do for B? Foiled it, cool. So when you foiled it, what was the function that you got?
Index.
The original function.
4x squared minus 28 plus 49.
For the moment, yes, FOIL this, okay? It was 1 raised to the 3rd power, cube it, okay? Do it 3 times. There is a way to actually do this without having to actually FOIL it all the way out, but you'll learn that in a couple of days. So your derivative should have been 8x minus 28, yes?
Yeah.
So then when you plugged in 2, what value did you get? Negative 12. And when you plug in 7 halves, what'd you get? 0. Good stuff. Now, if the slope is 0, okay? You remember that problem we did with the quadratic at the very beginning when we used the formal definition? And we ended up getting the slope was 0? And what was the tangent line? What did the tangent line look like? A horizontal line. So anytime you get that, that should let you know that you're either hitting a minimum or a maximum on that particular curve because the slope is 0. Okay? It's going to come back in a little bit. Okay? For C, what you guys get for the derivative?
3 over 2x to the 1 half.
You guys get that? Yeah? Okay. For this one, since we are going to have to evaluate it as 4 as well as 9, it might have been helpful to have it as a square root. Okay? Because when you did evaluate it at 4, square root of 4 is 2. What you guys get for this one?
3/4.
And for 9,
1 half.
yes? And the last one, D. X to the 4th over 4 is just the same thing as saying 1/4 x to the 4th. This is the same thing as saying 3 halves x to the 3. Okay? Don't let that throw you off any or anything like that. So when you took the derivative, you should have gotten x to the 3rd minus 9 halves x squared minus 4x plus 15 halves. At 5 and at 0. What'd you guys get when you plugged in 5?
0.
What'd you get when you plugged in 0? Questions on using your power rule? Good to go?
So,
Yeah, I mean, yeah, you plug in that the whole thing. You always plug in the original when you confirm with your calculator. You can include parentheses around the 1/4 and then x to the 3rd, but you don't have to. The calculator is going to read 1 divided by 4 times x to the 3rd.
Does it matter, like, since we got the equation in fractions, does the answer have to be fractions, or does that not matter?
Doesn't matter. Okay. Last problem. It says the curve y equals ax to the 3rd plus 7x squared minus 8x minus 5 has a turning point at the point where x is equal to -2. Determine the value of a. Turning point. What does that mean? Trevor.
means y is going to be equal to 0 because that's the cubic
Okay, we know we're dealing with a cubic, right? And you're saying that, now you said y is equal to 0. What do you mean y is equal to 0? The derivative is going to equal 0 because you are at this point. A turning point is basically like a max or a min. Okay, so once you hit that turning point, you're hitting basically one of the maximums and one of the minimums, which means your slope is going to be 0. Okay, so turning point means the slope of that tangent line is going to equal 0. The derivative at that particular point is going to be 0. And more specifically, when x is at -2. So we're going to have a turning point, a max or min, at -2. Okay? Now we're going to use all this information to determine the value of a. Well, we're dealing with the slope being at 0, the derivative of 7x squared? And what about the next one? And what is the derivative of negative 5? 0. So now that we have the derivative, we know two other pieces of information. We know that when x is equal to negative 2, the derivative should equal 0.
So put 0 into y and
You set it equal to 0, set that derivative equal to 0, and plug in negative 2 for x. That's how we go about finding the value of a. Because again, we're given those two pieces of information. The derivative had equal 0 when x was negative 2. So we do a little bit of math here. It's going to be 12a minus 28 minus 8. Combine like terms. And this is nothing but a linear equation that you solve. And a is you can always check by plugging a back in to the derivative, plug in negative 2, and your answer should